Today we're going to be learning about circles and arcs. So a circle is a set of all points equidistant from the center of the circle. So right here is our circle. And we have a center right there. The radius is a segment with one endpoint at the center and one on the circle. So here is a radius. Another radius we could have is that one, and we have another radius. So in this picture we have three. Congruent circles are circles with the congruent radii. So if we have two different circles and they have the same radius, then they're congruent. The diameter is a segment that contains the center of the circle and the endpoints are on the circle. So for instance, our diameter on this one goes through the center and on the endpoints of our circle. A central angle is the vertex is the center and the sides are the radii. So for instance, here's our two radii. So here is our central angle. Semicircle is half of a circle. So for instance, this part is half of our circle. And adjacent arcs are arcs with exactly one point in common. So for instance, if we had arc AB and we have C, arc AB and arc BC are adjacent arcs because they share one common point. Let's look at circle O. So circle O has AB as the diameter, and we know that the measure of the arc length BC is 47 degrees. So we need to find the measure of the arc length CAB. So that means we're looking at this arc. We want to know the measure of that angle. So in a circle, we have 360 degrees. So we don't want to use the 47, so we're going to subtract 360 by 47. So we know that the measure of arc CAB is 313 degrees. Now let's look at the two different formulas for finding the circumference of a circle. First of all, we have that the circumference equals 2 times pi times the radius. So this is going to be good when we know the radius of our circle. We also have that the circumference equals pi times our diameter. So whenever we know our diameter, that one will be a great one to use. We also have the arc length. The arc length can be found by taking the central angle, dividing it by 360 degrees, and then multiplying it by the circumference, which is 2 pi times our radius. So let's find the circumference of the circle in terms of pi. So we have the circumference equals, while looking at our picture, I know my radius. So I'm going to use the formula that circumference equals 2 times the pi times my radius. So I know my radius in this picture is 19. So now I can do 2 times 19, which is 38 pi. So then from here, we are now looking at in terms of pi. So there's nothing more we can do because we want to leave our answer with pi. So we just need our units, which is in inches. So our circumference of this circle is 38 inches pi. Looking at this next one, we have to find the circumference of a circle with a diameter of 12. So we have a circle. Here's our center, and we know we have a diameter of 12 centimeters. So if I have to find the circumference, and I know my diameter, I'm going to use pi times our diameter. So I have 12 times pi. Since it doesn't say in terms of pi, do 12 times pi. Round it to the nearest hundredth, it's 37. And round to the nearest hundredth means it'll be 7/10. So it'll be centimeters. The radius of circle C is 8 inches. We want to find the length of AB, so that means we want to find this distance from A to B on the circumference. So to find the length of the arc AB, we take our central angle, which is 85 degrees. We divide it by 360 degrees. And we multiply it by 2 times pi times by our radius, which is 8. So from here, let's start by doing 2 times 8. So we know 2 times 8 is 16 times pi. So here if we do 85 divided by 360, get the arc of AB equals, round is the nearest hundredth, be 24 hundredths times by 16 pi. So now the arc of AB, if I multiply 24 hundredths times by 16 pi, round to the nearest hundredth, is 12 600ths, and our units is in inches. For a circle of radius 6 feet, so we have our circle, here's our center, so radius of 6 feet. Find the arc length of a central angle of 6 degrees. So we have our central angle is at 6 degrees, so we want to find this missing arc length right here. So we know we take our central angle, which is 6 degrees, divided by 360. We're going to multiply it by 2 times pi times our radius, which is 6. So 2 times 6 is 12. 6 divided by 360, rounded to the nearest hundredth, is 2 hundredths. We're going to multiply that by 12 pi. So 2 hundredths times by 12 pi is 75 hundredths, and our units is in feet. We have the diameter of a basketball rim. So here's our basketball rim, and the diameter is 18 inches. We have a standard basketball that has a circumference of 30 inches. So if we have our basketball here, the circumference, so looking around, is 30 inches. We want to know how much room is there between the ball and the rim in a shot in which the ball goes in exactly the center of the rim. So that means we shoot the ball and it goes in our rim there. So we want to find the distance around the basketball and the rim. So let's start by saying, well, we know the circumference of our basketball is 30 inches. Well, we can say, well, the circumference equals pi times our diameter. So 30 equals pi times the diameter, because we're substituting in for C. So if we divide both sides by pi, 30 divided by pi, rounded to the nearest hundredth, is 9 55 hundredths of an inch. So that means the diameter of our basketball is 9 55 hundredths. So to find what's left over when we shoot the ball, if we know the whole rim has a diameter of 18 inches and the basketball is 9 55 hundredths, we can take 18 and subtract our 9 55 hundredths. So 18 minus 9 55 hundredths means that there is an extra 8 45 hundredths of an inch left of space. But since the ball went through the direct center, we need to divide that in half to find out how each spacing is. So if we divide that by 2, our final answer is that there's 4 23 hundredths of an inch of space all around that ball and the rim.